Well, hi there, apes. Coming at you with a lesson on forestry. I think my previously recorded video is not functioning so well, so I'm just going to record a new one. At this juncture in the course, you're at the end of the semester, and the idea is that within agriculture, there's kind of this subfield, forestry. In fact, you'll see the USDA, or U.S. Department of Agriculture, oversees the, for example, U.S. Forest Service. So even on a governmental level, we think of forestry in America as being a subset of agriculture. You'll also notice that a lot of the impacts of different forestry practices are really assessed for their relative ecological benefit or detriment by looking at their impact on soil. So just like any other agricultural practice, although this is a special subset. At any rate, let's get into it. Some notable things to be aware of. The U.S. forest system was created by the Forest Reserve Act of 1891. As you'll read about in the case study that you're working on this week, it doesn't really give a very clear direction. Some follow-up laws, the most important of which I'll talk about in a minute, which were passed later, give direction on exactly what the purpose of the U.S. forest reserves is to be. But in 1891, at least, the government says, well, it'd be okay for the president to set aside some land as a forest reserve. And the idea there, the undertone was that it would be for protection of that forest. And we'll ask what protection looks like in a minute, of course. So some early forests that are set aside are actually in places like Yellowstone and Yosemite, and they become either part of or kind of protected areas around the national parks that either were current at that time or have developed since. Again, this was, it gave rise eventually, not too long after, about a decade after, to the U.S. Forest Service as a branch of the USDA to manage these forest reserves that were being created, which are now referred to as national forests. Eventually, probably the most significant law for you to understand, both for the case study and for just understanding forestry in America. Eventually, in 1960, this Multiple Use Sustained Yield Act was passed. And what this act basically says is the forest reserves are to be managed for use by multiple interested parties, and their interests are to be balanced. So in other words, if I'm a fisherman and you're a hunter, and there's also a person down the street who works in timber, and then there are bears and deer and other organisms that use the forest, and there are people who rely on getting water from the forest, that goes back to our ecosystem services discussion. All of those parties' interests should be balanced by the forest manager. If that sounds like a lot, yeah, it is, and that's kind of what the case study is all about. But that's at least the guidance, is that we're managing for sustained yield in multiple uses of the forest. Sustained, of course, means that it's not being degraded over time. The resource is recharging itself. There are enough fish for the fishermen, enough animals for the hunters, enough timber for the foresters to sustain their lives, and enough water purification going on to ensure that people in that watershed have access to clean water. Where those things come into conflict, again, that's the role of the forest manager to figure that out. This also ties into the concept of a maximum sustainable yield. And if you go back to thinking about the shape of a logistic growth curve, right, the S or sigmoidal shape of the growth curve, the steepest growth rate is right in the middle of that curve. That's where the curve is going most vertical. So one principle in management is actually, you don't need to protect everything. You need to make sure that you're not going to the bottom of the curve where there's nothing left. Instead, a good guideline is, if you're managing resources to be something like halfway to what they could be, like carrying capacity level, then there's a potential that's a good starting point. That's obviously not ironclad. Sometimes that's not going to work out. Sometimes having half as many as there could be is not actually going to be a sustainable situation. However, in general, if you're managing to about half of carrying capacity, the assumption is that gives plenty of space for the resource to grow and recover, while also giving you plenty of leeway to harvest. And the rate of recovery is the highest because that S-shaped curve is the steepest rate in the middle. That's the idea of maximum sustainable yield. So you might say, it's not that you can't touch any fish or you can only touch a few fish. If you have good, robust populations, you could be harvesting good numbers that are recovering every year because you're somewhere in the middle of the number there could be. Not too few, not too many, maximum sustainable yield. A general guideline, not an ironclad rule. Clear cutting is the distinction that on this list that I most want to emphasize to you alongside selective cutting. there were any two terms the College Board is really going to want you to know from this forestry unit, it's these two. Clear cutting says to cut the forest down and to harvest the timber. Don't worry about it, cut the whole thing, kind of like taking a lawnmower to it, except you're probably using chainsaws and or bulldozers and other heavy machinery. Clear cutting results in a whole litany of environmental impacts, which we'll talk about in a minute. The main benefit is it's the easiest way to make a lot of money off of the forest. You can cut it all down relatively cheaply using heavy machinery, which might remind you of agriculture, where industrial scale is really saying the whole thing treated the same way. Machinery powered by fossil fuels being used, do it at a very large scale, maximize your profit within the economic system that we're running. That's not a value judgment, that's just kind of a statement of what's going on. Selective cutting, on the other hand, is a bit more careful. This would be almost like rotational grazing with animals or something, except humans cutting out trees. You're going through and rather than taking everything, you select out certain trees, cut them, and other trees you leave standing. There are different principles of how to do this. It is a much more complicated subject than just take half of them and leave half of them, and it doesn't matter which ones, or every other in a row. There are principles of forestry that you could study at a collegiate and postgraduate level of how to do this in different terrain types and different forest types. It's highly complicated, but the basic idea is selective harvesting says, don't cut them all, leave some there in order to provide services that are good for humans, that are good for the environment, and that potentially allow the forest to recover better. The final set of terms on here will help us to inquire perhaps into the different results of these two practices, selective cutting versus clear cutting. These are focused on things like soil erosion, stream temperature and sediment loads, and even age of trees. So let me clarify. Soil erosion is much higher when there's been a clear cut. You probably aren't surprised by this. If you clear cut all the trees out of an area, you're exposing the soil to direct hits by precipitation, which will wear the soil away, direct exposure to wind, which wears the soil away, and it's not held together by the root networks of trees that would normally prevent it from washing away. Therefore, it washes away much more easily. All of those things are at play. In intact forests, if you've ever gone for a walk in a forest during a spring rainstorm or something, you know that you don't hear water hitting the ground, you hear it hitting the leaves. And next time you do that, you should be thinking, thank you, trees, for preventing soil erosion, right? Also, leaf litter and plants growing in the understory of, say, an old growth grove, those are all preventing direct impacts by water and wind and holding the soil together with roots potentially, right? Or just holding it together underneath a layer of organic matter. If you do selective harvesting, you provide a greater likelihood that soil erosion won't take place because you're leaving some plants in place to accomplish those functions. Now, follow up, if soil erosion does happen, where's that sediment going? Well, it's going into streams. So obviously stream sediment pollution in an area that has been clear cut would be elevated. And the College Board does love to ask about this. Do you know that if a stream is in an area that has been clear cut, its sediment loads will go up? Another thing they like to ask about, perhaps less obvious, is its temperature will go up. Because streams are shaded by trees, by an intact forest. If you clear cut the forest, then you will have sun directly impacting that stream. The stream temperature will rise. Think about ecological tolerance, tie back to a Unit 2 concept. Organisms have certain ranges in which they can exist, and a lot of freshwater species have somewhat narrow ranges of ecological tolerance when it comes to temperature. Certainly they could be breached, their tolerance ranges could be breached, they can end up in a zone of inability to tolerate that particular factor of temperature if there's been a clear cut in their region. So these things are worth thinking about. A final one that I'll mention that's not on my list here, but it's a good one to think about. You'll hear about this in the case study at length. If you clear cut and then the system does recover, let's say everything is fine, the soil doesn't erode, trees start growing, and hey, best case scenario, all of the trees that recover in that area are the same age. That isn't inherently an issue, but here's the thing. In an intact primary forest, primary means it's never been cut. So it's basically an old growth forest is likely a primary forest in North America, because old growth means hundreds and hundreds and hundreds of years old. So older than Western civilization in the North American continent. So old growth or primary forests will have a whole mixture of trees of different ages, and they play different roles. and they have different susceptibilities to pests. An even aged stand of trees that results after a clear cut, even in the best case of actual recovery of the forest, that even age stand, let's say a pest comes along that loves to infest 15 to 20-year-old trees. You might think, oh boy, I'm glad I'm not a tree. Well, at any rate, that pest is going to have an easy time with an even age stand that was clear cut 15 to 20 years ago. That's heaven for that pest. Think about monoculture in agriculture. Perhaps you can now see why forestry is a subset of agriculture, in the sense that sustainable techniques and unsustainable techniques are thinking about the same types of outcomes and the same kinds of issues. So an uneven aged forest would be useful. Now, finally, to conclude the presentation, just to show you a few maps here. Federal forests are the dark green here. There are a bunch of land types here. National Forest System lands are in dark green. You'll notice most of the East Coast, given the history of the country, most of the East Coast was settled before 1891 when this Forest Reserve Act created national forests. So I thought I would just mention to you, for those of you who are on the East Coast, or really if you're east of the Rocky Mountains, there aren't a whole lot of national forests around, maybe unless you're in like, northern Minnesota or Michigan. Or Wisconsin, where there are some national forest lands up there, maybe in the Smoky Mountains in the Appalachians, or some parts of, say, like Missouri or the Ozarks. Other than those very rugged territories, not very many national forests in the East, because most places were settled, cleared for farming during colonial era and so forth, and are now, and to the extent that you're in Connecticut, for example, you're probably in secondary forest. You're in areas that were cleared for farming and are probably on some scale of recovery, whether it's 50 years old, 100 years old, maybe a couple hundred years old, but at some point in the past probably cut. A good indicator is if you're hiking out in the woods and you see stone walls, that was a farm. And the woods that you're walking in were once not woods. They were cleared by early colonists or by maybe folks living in your part of the country in the 1800s, for example, maybe even more recently, depending on the age of the trees that are there. But you're in secondary forest, not in primary old growth. On the West Coast where I am, there's a whole lot more primary or old growth, especially in the North Coast region of California. I'm in the central part of California, though we call it Northern California. It's really central in terms of the geography. The Northern Coast region has the most amazing redwoods. I highly recommend Jedediah Smith State Park, Jedediah Smith State Park in California. If you get a chance to get out here and get up far north, absolutely the best redwoods in that I've ever seen in the world, certainly that I've seen in California. And up through Oregon and Washington, quite a few national forests. Now, national forests now are not like, they're not managed, as you heard, as protected areas. Does not mean that you can't cut trees in them. It just means you have to get permits from the government. You can't cut them however you want, as if they were privately owned. The number one site of forest loss in America right now is the American Southeast. That's probably, you could argue, because those are privately held lands, corporate, family owned, other private ownership, which doesn't inherently mean that they would be cut, but it means there's a lot less restriction on cutting. And if there's demand for timber, which interestingly, as you'll hear about later in the year, there's a lot of demand for timber right now because of biofuels in Europe. So most of that timber is being cut, pressed into wood pellets, which are shipped to Europe so they can make quote unquote sustainable, renewable energy. Now we might ask if that's really sustainable and renewable that you're cutting down American southeastern forests. Did I say Southwest? I meant Southeast if I said Southwest. American southeastern forests, and shipping the timber over to Europe to claim to be saving the planet from climate change by not burning oil or fossil fuels, especially since you're burning oil to ship it across the Atlantic. But anyway, we'll get into that more later. Most of the intact primary forest is in the West, but actually the number one place you'd find a lot of intact primary forest, Alaska. And if you ever get a question about where's there the most forest, it's gonna be Alaska. You're going to study in your case study the Tongass National Forest. You're going to specifically study Prince of Wales Island in the far south of the Tongass National Forest. And you're going to hear about clear cutting along roads in the Tongass National Forest. This is a current controversial issue as different presidential administrations seek to protect the Tongass from road building or to encourage road building in the Tongass. This has been an open question. Roads in a national forest lead to cutting. And that's what you see right here in this image. And boy, can you imagine what's about to happen to that waterway that's beneath that clear-cut slope. So at any rate, thanks for your attention. I hope this was interesting, and I'll see you all in the next video.